in the electrical engineering field. Its main function is to step up and step down the voltage. While doing this, it will have some primary and secondary winding which will be linked through some transformer core. So as you are first time at learning this transformer, so it is always good to start with very basic concept of flux and all. So let us start the transformer. Now as we know that, let's say if we have one conductor in which current direction is in upward direction, so basically just surrounding to that particular conductor there will be a flux. Now in order to decide the direction of flux, so there is a, like, you can put, let's say this is the conductor, and if you want to check its direction, so what you can do is you can put your thumb in the direction of current and your finger will be indicating the direction of flux. So here in the upward case the direction will be of flux will be in anti-clockwise. Now if your current is in the downward direction, then also flux will be produced, but flux will be into clockwise direction like this. So this is something showing a flux. Now here, as there is not having many turns, so this flux will be very low. So here we have to transfer a power through flux path, so that's why we have to make flux very powerful. So in order to do this, what we can do is, like, this is another example where you can take multiple turns. So here we are having, let's say if current is flowing like this, so current will flow through this. So we are having 4 turns here. So that's why the flux which is contributed by each turn will be add up and the resultant flux will flow like this. But the thing is, like, here this flux has to pass through the air, because here it does not have any magnetic material. So it will be like always some north to south, right? It will, let's say, north and south, so it will originate from north and will end up at south. But here there will be a problem, like due to air gap, because air is having a higher the magnetic material. So here some magnetic material is there, and on the one limb of magnetic material this winding is there, so the current will flow like this. And like, what will be the direction and how to decide? So in order to decide now the direction of flux, what we have to do is, our the finger would be in the direction of current. So let's say if we have multiple turns, so our flux will be in direction of. So in the previously what we have seen, our thumb is in the direction of current and our finger was in the direction of flux. Now if we have multiple turns, then our finger would be in direction of current and our thumb will be in direction of flux. So let's say, for example, in this case our flux would be in the opposite direction, so it will be downward. So it will so while the polarity of the supply voltage changes, so with the current direction the flux direction also will change. But one thing you can notice here, like the flux which was previously very much high in the air gap will not be there, because now this particular ampere turn means the magnetic field strength is having some magnetic path. Okay. Now while practically is if you look at any transformer, so this will be the kind of bobbin over which people used to take some turn like this. Okay. Now here this is your magnetic material actually. So from here to here, this is your magnetic material. Okay. And mostly while you look at any core, so the central limb has the area, like this is the central limb. So the central limb has area which is twice than the end limbs. So what I am trying to convey is, like, this is, let's say, L, and this would be 2L, and this would be again L. Now if you are doing windings on the central limb, okay, then it is something known as a shell type transformer. And if you are making windings on the both the limbs, then it is something known as a core type transformer. This is core type transformer, okay. Now mostly people use EI. So on the downside this is having shape of E, and on the top side I. So EI type of core people are using. Sometimes they use EE core. So on the both the side there is one E on the downside, and on the upper side there is a E core. Even you may find EI, EE core, then FF core, where you will find two laminations like this, one F, and on the opposite so you will be having this F. Okay, and while you join them, then it will take this shape. This is UI shape, so on the downside it is U, and the upper side it is I. This is LL shape, so here it is L, and here it is also L, and this is W, so U and U. So there are various types of core shapes are there. Now in the transformer what we will be having is a core, and on the core on the left side, left limb, there is a primary windings, like many turns will be taken and supply will be connected on the primary. On the secondary also there will be a turns based on the voltage requirement on the output. Okay, say for example, if you are applying let's say 230 volt, and if you are, let's say, taking almost let's say 300 turns, say for example, so on the secondary side if you want only 50 volt, so you would not take 300 turns on the secondary, so that would be in proportion to voltage. So if you want less voltage, then less number of turns you require to take in the secondary. Let's say if you want to increase your voltage, then you have to take higher number of turns as compared to primary windings. So this is all about some basics of transformer.